Welcome, everyone, and thank you so much for the time today. My name is Michael Wood. I'm out of the office of the field CTO here at Hashicorp. And I'm really looking forward to walking through a couple of key subjects that I think are impacting a lot of our industry these days. One is the industrialization of infrastructure in IT delivery holistically. That is, how do we make it very easy for folks to self-serve and accomplish great things in information technology, but also doing that with trust and or controls. And so we're coming to recognize with the level of risk that we have out in the marketplace in terms of breach, data protection, legislation, et cetera, that we need to do a better job of deciding when and where and how to extend trust to systems and applications as we go. So a lot of what we're going to be talking about today is going to be framed around lessons that we've forgotten, especially via things like industrialization. So if we think through what, when I talk about things like industrialization, we're talking about how do we get very efficient in our ability to automate the delivery of some good. Naturally, in manufacturing, we might think automobiles, airplanes, and those types of things. But when we're talking about information technology, it's really the same thing. It's a set of schematics that are going to enter an assembly line and kick out an experience on the back end. So what can we learn about those previous revolutions, technological revolutions, that we can apply to IT? And then how does HashiCorp look at this kind of industrialization through the lens of what we call the cloud operating model, which ultimately should lead us to a place where we can deliver IT capabilities as a service. So let's jump in. HashiCorp, by way of introduction, has grown organically. Armand and Mitchell, the co-founders of HashiCorp, will tell you that they were basically frustrated developers and operators that really saw the need for automation in order to get very efficient in serving their customers. So rather than recreate environments all the time, they thought, hey, wouldn't it be cool if I could bin pack an operating system and then use something like Vagrant to stand up a virtualized environment so I don't have to rebuild my laptop when I move from a Windows client to a Linux client. And that progressively grew, right? So if I can do that for one VM, can I do it for a whole whole sets of highly complex distributed systems? And maybe that looks like Terraform. And as we're building out that automation, we realize that networking has to come along for the ride. So maybe we need some tools to help us with networking and then security and so on. So all that to say that we organically grew as we realized that there were gaps in our ability to automate and deliver IT as a service. And so that's where HashiCorp has come from. And now we're serving some of the world's largest organizations at scale. Now, the problem that we're trying to solve is we know that we need to go very, very fast. Study after study, year after year, report after report will tell us that the faster we can go through this learning process of releasing software to the public, learning whether it's a good idea or a bad idea to continue moving down this path, and then replacing it or improving it, that cycle is what really begins to differentiate companies from the rest of their industry. So the State of DevOps report will get very, very clear here that the folks that are outpacing their competitors are delivering way, way faster and are recovering in production when there is some form of failure way, way faster. So we know we want to go super, super fast. But as we go fast, we realize that we introduce the possibility for fragility into our systems. Something could get misconfigured. We could implement something incorrectly, which leaves us open to a potential breach. Maybe it's an S3 bucket that is left open to the public internet, which exposes Facebook data. Maybe it's a misconfigured web application filter and a leaked password, which results in an SEC fine for Capital One, or it's networking rules that are too open, too trusting, so an attacker can come through the air conditioning unit into a local store, retail store, and then ride that all the way back to corporate to get customer information. Or maybe it's something that's a little bit even hard for really even best practices to catch in some cases, like a supply chain style attack like SolarWinds. The idea is, however, that there's just so many moving parts out there that these attacks just seemingly keep coming. And I'm not running through those to use fear, to like we have to do something. It's terrifying. No, that's not what I'm saying. What I'm saying is that our systems are so complex. It's very, very difficult for us to keep a handle on all of it, right? There's just too many moving parts. Within the private data center, we have, OpenStack or VMware and bare metal and dedicated systems, mainframes and packaged applications and third-party SaaS providers and all of this type stuff that typically has been moving a bit slower, and we have lots of change tickets for managing that process, and there's a lot of manual processing that goes into that, which is very difficult for us to audit. If somebody comes in through a UI and makes a few changes to an environment, I have to scrub logs, right, if it's outside of a ticketed process or something like that. And so we try to modernize that by introducing new platforms, maybe Kubernetes, and that becomes kind of a bolt-on experience for our private data center. And it has its own operating stack, top to bottom. Maybe you're using Kubernetes and then you're using Istio for some service mesh, and then Calico or Cilium for, kind of those IP addresses, static IP connectivity outside of the cluster, tying clusters together. Maybe you're using something like a Tyke for API gateway, and so on and so forth. So the whole idea is that there's a whole new ecosystem of operational products around that individual platform, which really don't apply to the rest of the environment. So now I'm running kind of multi-cloud, if you will, but I'm inside the private data center. And then we start stacking on the public cloud environments, which are a bunch of infrastructure that I don't actually own. So while I'm using a WAF that's been provided by a third-party cloud provider, I don't actually operate the WAF. I send it instructions. But if there was a team on the other side of that are responsible for that individual service, that's a third-party company, how far should I trust that device? How far should I trust those controls? If a public cloud vendor is breached, how much of my infrastructure has been exposed because the cloud vendor was breached? So we start to have discussions like, okay, maybe attacker is not always outside of my perimeter. In this type of a world with this picture, my perimeter controls are very, very logical. It's not actually a physical construct. It's not a key card to get into the data center. I have to sort of assume that the attacker is on my network and is pretending or trying to pretend to be a trusted resource or a trusted IP on the network. So I have to fundamentally flip my notion of trust and identity and move away from those static constructs that we were used to, right? So normally I look at a firewall and I have IP this can come through the firewall to talk IP that. And the load balancer says this IP can talk to the IP, TCP, IP, FTP. We have all of those various routing rules. And basically we kind of were saying, like, if it's on this table, it's probably good. But it's very hard to understand what the intent behind that rule was, because there are IPs. I don't know what's behind that IP. So if I trust the IP and someone upstream is able to come in over that IP, oftentimes it's very difficult for me to defend against that traffic, because I need to move away from IP into more identity. Now, as I mentioned, lessons that we've learned that we really need to begin applying. One of the reasons why this world is so complex is because we're sort of artisanally creating these things, these applications, and the environments that those applications run in, sort of from the ground up. And we've learned this through multiple iterations of industrialization. So in this case, we were talking about how we manufactured planes in the United States. And it was generally a bunch of engineers would get around a plane and build it from the ground up, hand fashioning rivets and fasteners and hand shaping aluminum sheeting to make the walls of the fuselage, et cetera. And in partnership with Ford was basically advising in this case, you should use machine parts. Why are you creating everything from the ground up? You should automate some of this. You should have more of an assembly line concept. And I think that's the approach that we've typically taken to cloud deployments. We get a bunch of brilliant people around an experience. We handcraft it from the ground up. We go in through the AWS console. We say that we want this much compute. We want the storage. I want this S3 bucket. And so I sort of create a somewhat handcrafted experience from the ground up. But that's difficult for me to manage day 2, 3, 4 across a fleet, across anything of scale. And so I think what most organizations are trying to do is figure out, how do I incorporate more of that industrialization thought? These clouds are basically API sets that I can send instructions to. And so I'd like to very cleanly send instructions to them. I want to measure things for accuracy. I want to measure things for cost. I want to be very proactive in the way that I secure my environments, in the way that I manage costs, in the way that I extend connectivity, and especially how I'm handling things like data. Am I encrypting everything, right? If I'm not managing a network device and I'm passing traffic through that network device, it's probably better if that network device never has a chance to understand the data that's passing through it. I want it to be encrypted in motion. So how do I establish mutual TLS through into the cloud such that the local network devices have no chance to understand what data is flowing? So these are kind of some concerns that I start to look at as I think through this multi-cloud and all of this complexity. And I want to take that same assembly line view, that I'm still going to have specialized groups of individuals, but that I want them working on things that they are specialized to adapt to work in. So I want networking professionals doing networking things. I want security professionals doing security things. And I want core infrastructure doing core infrastructure, and developers developing. And so if that's what I want to see happen, then I need very clean sort of dividing lines. And you can think of this as like role-based access control, that only networking folks can change networking modules, and you will only consume networking via this automated pipeline, because that's the way we can ensure that we are being opinionated and secure and well thought out and governed. And so we want to think more along this assembly line kind of an approach. So let's kind of break that down. As Hashicorp, we started with the idea of automating the delivery of distributed systems, or initially, VMs, obviously, and then as those began to spread into more complex constructs, it led us to something called Terraform. And Terraform thinks about this world as infrastructure as code. And you'll hear us talk about infrastructure as code, but think of it like, what I'm trying to do is establish an intent. This is what I want the infrastructure to look like. And then that intent can be audited. So I can read it. It's been written down. It's been typed out. I can compare differences between this version of the infrastructure and that version of the infrastructure. And now I've got kind of some controls over how my infrastructure is changing over time. The other thing that gets interesting here is when I go to press, that machine, I want this machine to press that environment into reality on a particular cloud infrastructure, maybe on-prem. I would like it to pass through a policy engine gate. So I would like to have that automation go out and see what's already there. If there's already a door in place, don't put another door on that same side of the car. If there's not a door, put the door on, right? That would be a form of kind of intelligence in my automation routine. I want it to understand what's actually running out there, which is what we would call state. And then what I want it to do is tell me what it plans to do to either add the door or not add the door. And then I want to enforce a policy which says, is that door too expensive? Is it the right color? Is it secured appropriately? I want to run policy as code to make sure that any changes that go into this production or non-production environment meets all of our GRC concerns top to bottom. And so if I were to break that down a little bit, Terraform provides us with a good, clean way to segment environments, to segment teams, to control access, to enforce policy, and to basically automate the entire supply chain of delivering infrastructure. With more than 2,000 providers out there, we can manage just about everything under the sun. If there is not a provider out there, we can build one because they're just APIs, but there's such a rich ecosystem of providers that abstract away the details of working with whatever that technology is, whether that technology is AWS or Datadog or Kubernetes or VMware. I want to have a simple declarative way to say, I want a VM, I want it about this size, I want it to be like something along the lines of this image, and here's my credentials, make it so. That's what I want to see in my code to simplify the delivery of infrastructure. And I want to have a good, clean way to manage end-to-end the flow of infrastructure delivery. And not to spend too much time here, but again, I'm talking about separating out different groups, chaining them together to deliver something of larger value with complete governance end to end. This provides me with that centralized audit plane, controls, policy engine. I can see a chain of custody for everything that gets deployed within my environment on any cloud at any time. And so once I have that, I have the beginnings of a trusted environment. I know that things have been provisioned and it's been done with best practices and GRC compliance have been attested. Now, to go a step beyond that, I need to be able to manage identities and credentials and access, right? So I don't want to have passwords floating around in the clear, right? I don't want users with a service account usernames and passwords and things like that that are not being managed appropriately or hidden from my source code repositories and things like that, or my source code itself. So is there a way that I can inject secrets into the environment or manage them in an abstracted way so that the systems aren't aware of the core secrets? And then from there, can I also do this with encryption? Can I centralize my encryption services in the way that I handle PII? And the answer is yes. And so with Terraform, we think about this in terms of Vault. And with Vault, the general pattern we have is a client asserts an identity and it's trying to request access to a given system. Maybe it's a database system on the back end. Vault will examine root of trust. It may do multi-factor authentication. Maybe you're using Ping or Okta. You've got local Active Directory or LDAP as your root of trust. Maybe I want to bring the key into the cloud. I want to manage the cloud access based on on-prem access control lists and policy. Whatever the pattern that I want to implement, Vault will handle the workflow of managing that credentialing. And so if I see that there is a policy and you are a trusted identity, I can create the user ID and password, or I can grab the static account credentials and I can send you, Mr. or Miss Application, a token properly encrypted so that you don't actually have any possibility for credentials to leak. Now, that fundamental indirection opens up a world of possibilities because I'm never talking directly to the system alone. I'm going through my identity attestation workflow. And so I have the possibility to do things like encryption as a service. Maybe any government identity that comes in, I would like to have it format, preserving, encrypted, and then stored on the database so that the cloud native database that's managing my information never sees personal information in the clear. Maybe I want to do wholesale encryption of all financial trades that come through the system. Whatever the case may be, I'm sitting between the client and the end system that's going to be receiving the data, and I'm managing encryption and all of the keys. So there's no chance in this case for a leaked credential. I'm setting time to lives on those credentials. I'm managing the complete life cycle end to end. So this provides me a much cleaner way to deal with encryption policy holistically and identity holistically in a multi-cloud environment where I'm protecting myself, if you will, against systems that I don't manage and I'm not, I don't have a perfect understanding of who has access to the underlying infrastructure. So once I have this finally attested identities, I know who is who. I can start establishing things like network policy against that. So think authentication authorization. So do you have the rights to talk to this foreign system that you're calling to? And what is the security policy that's enforced there? Does this require mutual TLS? If it does require encryption, go get your certificate, and come back and complete the handshake. So I'd like to take that type of policy and I would like to distribute it out to the endpoints within the environment so that networking becomes much more dynamic. And that's where Consul comes in. And Consul originally started as a service registry with health checking. So the idea is we kind of have these agents, all new services will kind of dynamically register. That comes back up to our main control panel, or my control plane will have an active record of all named services under management. And I'll have a centralized place where I can establish things like intentions on who can talk to who, when, and under what circumstances, et cetera. So think in terms of, for those of you who are into networking, kind of layer 4 up to layer 7 controls on networking around how services can talk to services. So it started out as a registry, health checking. The idea is that because I know IPs are going to be moving quite a bit, I want something that's a little bit more static, like a name. And then I want that name vetted with an identity or something like an X509 certificate that's been signed by a root of trust. So think of it as like you show up at the airport and you bring your driver's license to prove that you can go ahead and get on this airplane. So I want to have that form and I want to have it distributed out to the endpoints. And once I have this kind of catalog of everything that's running, I can start to do things like that policy, authentication, authorization, and routing, which leads us into more of that kind of multi-platform service mesh. So one thing that's interesting about Consul is it's not baked into any particular platform. In other words, it's not like a Kubernetes only style service. We do service mesh style deployments in raw VMs. You could be doing things on bare metal. It really doesn't matter to us how you are managing kind of that end-to-end connectivity. But the idea is Consul will help you automate all of it, including, and so I mentioned the health checking and monitoring on one side, the multi-platform service mesh on the other. And in the middle is I can have my load balancers and firewalls use the service mesh as the source of trust for what IPs should be getting routed to. So if I have a firewall or a WAF that needs to receive an update, I can fire an event from Consul and I can actually get updates out to those networking devices. We can get into detail when we have more time. But for now, let's just say that at this point, the whole concept behind Consul is to automate as much as we can end-to-end connectivity in a multi-cloud world across WANs, across different platforms, on-prem, off, whatever it is that we're trying to do. We feel like there's a possibility there that Consul could be a good fit for end-to-end network automation. And so finally, so now I've got networking provided, I've got identities. So my core control planes of identity and service registry are in place. I've got a control plane now for infrastructure. All of that is trusted. And now I need to manage applications on the infrastructure. And so I need to have a good, clean way to schedule applications. So we also provide a product called Nomad. We know there are other schedulers in the space. But ultimately what I need is I need a very simple job scheduler that divorces operations from developers. I really want developers to be able to tell me a little bit about how they want their application to be deployed. And I want operators to have the freedom to come in behind the developers and quiesce traffic off of 10 servers and replace them with 10 new servers and do whatever administrative tasks they need without being disruptive to the workloads the developers are running. So I need some form of indirection there. And ultimately, we see these as kind of the core concepts behind each one of those control planes that we want to bring into, that we really need to get good at managing if we want to industrialize the delivery of IT with good controls. And that's where these products are going to sit. Terraform for provisioning, Vault for secrets management and security, Consul for service registry, mesh, network automation, and then Nomad, and then some other schedulers like Kubernetes and others in that space for indirection for the developers. So as we close today, really think through how we use identity as the new control plane. Identity is where I can base my policy and how I can manage access to clouds and systems and so on. I want developers to be focused on end users and not on, call it the complexities of infrastructure deployment and those types of things. I want to increase things like the rate of change in my passwords. So I want to have rotation policies, time to live. And so I can do that through automation. I can bring more dynamism to the way my networking is moving around. I can be restriping environments through Terraform so that I keep malware constantly getting scrubbed out of the environment, et cetera. And all of this centralizing coming through these control planes makes it much, much easier for me to drive audit and compliance for federal regulations and those types of concerns. So hopefully that was very helpful. I know I needed to move really quickly, but I wanted to introduce you to a handful of ideas. And if you're interested, please do feel free to reach out to the local team. Let's get together and talk through these in more detail. Thank you very much. And I hope you're having a wonderful event. Cheers.